Hello guys, this is Farhan from AlgosFromScratch, and I welcome all of you to this amazing YouTube playlist on building DistilBERT model from scratch using PyTorch. This is the fourth video of this playlist, and we are going to discuss the tokenizer specific to the DistilBERT model. So we are going to start officially building our own model. So for that purpose, we are going to need this information of tokenizer because the tokenizer values, if you remember, we discussed here these input values basically, and the attention mask, we get these values from the tokenizer. Okay, so this tokenizer is very important because we will be getting values from this tokenizer, and so we will have to prepare an architecture that is compatible with the tokenizer itself. Okay, so starting with the concept of tokenizer, a tokenizer is nothing but, you can say, a box. Okay, at abstract level you can consider it a box. We pass some text to this tokenizer. I like this. Okay, and this text is then converted into list of tokens, like I like this. Also we get some input IDs, like maybe 102 0 1056 3928. So these will be the input IDs. And also we get, for specifically this BERT family, we get the attention mask, that is nothing but the binary values, ones and zeros. Okay, so we get these outputs from this tokenizer. Now let's discuss the tokenizer that specifically we use for the DistilBERT, because we are going to have an architecture that is compatible with the tokenizer from DistilBERT. And as I mentioned, we are not going to build our own tokenizer. So for this, now let's come to this coding screen. This notebook is the previously used notebook. In our last lecture, we fine-tuned the DistilBERT model using Hugging Face, and this is the same notebook. So on this screen, let me just show you what a tokenizer object is. It has basically the name or path, that is the DistilBERT base uncased, and the name of the model, and then this vocabulary size. This vocabulary size is very important. If you look into this embedding layer of the architecture, you can see the lookup table over here. This lookup table is basically the vocabulary size time dimension. Okay, so this is very important for building our embedding layer. Okay, then we have model maximum length. It is 512. So it is very important for building this positional lookup table. We will be building this position lookup table with the help of this maximum length size, maximum length. Okay, so this maximum length is, you can change it, and it will be the lookup size will also be of that maximum length that you have. Okay, so here you can see we have 128, so you can change it. Okay, it totally depends upon your data set. Okay, then we have padding rules, like the right side, it will be adding the padding tokens to the right. Also the truncation side, that also is the right, like tokens from the right side will be truncated. And if we have, let's say, more than the allowed limit, okay, the maximum length. Then we have some special tokens. These special tokens are very important. You can see these special tokens have CLS token, and also the pad token that we were just talking about. This CLS token, if you remember, here in the overview, we pass this CLS token to the classification head, and this CLS token will be responsible for the classification task. Okay, so this CLS we are going to use for classification purpose. Here in this specific scenario that we are working on, we are going to work with padded tokens. SEP mask, we are not going to use them. They are some task specific special tokens. So this is the unknown token that is basically used to handle the out of vocabulary kind of situations, okay, in the tokenizer. So let's say we have a token that is not available in the tokenizer dictionary, then the tokenizer will be assigning this unknown to that specific token, okay. Now what is next? Okay, so let me show you the tokenizer. Okay, here let me show you the tokenizer dot vocab size. Okay, and tokenizer. Okay, tokenizer dot vocab size. So this is the vocab size. We already have this over here. And if let me just execute this dir on this tokenizer, so we can see all these. You can find this map special tokens over here, of course with the tokenizer. Okay, so these are the special tokens. Okay, and then we have the some important. Okay, so we have this encode function. This encode function is used to encode the values to input IDs. Okay, and other than this, convert IDs to tokens. This is a very important one. Let's just use it. Okay, so let me call this, and over here let's say convert IDs to tokens. So I know that this 101 is used for CLS, so you can see here. Okay, so whatever token ID you give to this function, you will get the token against that ID. Okay, and this is the convert IDs to token. So if I search it, convert, let me search it. I am searching something special over here. So convert to native, convert encoding, convert a token to ID with added vocab, convert ID to token, convert IDs to token, convert token to string, added token, token to IDs. Okay, this is what I am looking for. So yeah, now if I just paste it over here and pass this CLS like this, so you can see the same token ID, okay, over here. So yeah, this was about the special tokens and how we can convert IDs to tokens and tokens to IDs. Okay, so the next is tokenizer vocabulary files name, and in this we are going to discuss the tokenizer.json. So if you have executed this notebook, you must have this directory over here containing all the files related to the model and tokenizer. Over here you can see we have this tokenizer.json. Okay, just click on this download and download the file. Okay, and then open this file. Okay, yeah. So this tokenizer.json is basically the complete JSON file where we have all of our special tokens, their input IDs. So this JSON file is used by the tokenizer to tokenize basically the input that we pass to the tokenizer. Okay, so here you can see the fixed padding to the maximum size, because we have executed this tokenizer with 128 maximum size, so that is why we have 128 maximum length, and padding is again to fixed to that maximum length. Okay, so then we have the padded tokens and its pad ID, and then yeah, here, and then this 100 to unknown. Okay, CLS, it's important, it's 101, then SCP 102. So whenever we pass the input to tokenizer of these BERT based models, so this BERT family wraps the input text with these two special tokens, CLS and SEP. CLS to the far most left side, like the text then starts with CLS token and it ends with the SEP token. Okay, so this is about the special tokens, and we have the complete vocabulary over here. You can see all of the tokens with their respective input IDs are basically here. So whenever we pass text to this tokenizer, what happens behind the scene, tokenizer gets the input text and tokenize it into subtokens, just like here, as I mentioned. So each of this token is then passed to the tokenizer dictionary, and that dictionary gives us the respective value that is the input ID, okay, against each token. And then we use these input IDs in our model. Okay, so if you look into this model architecture here, you can see input IDs, they come from the same tokenizer.json file. Okay, so this is about the tokenizer.json. You can explore it further, just go and look into this. You will find different values against different tokens. Okay, and I will show you some of the values when I will execute a small sentence, and I will pass it from the tokenizer. So I will show you then the input IDs against that specific subtoken will be there in the tokenizer.json. Okay, and then we have this attention mask. Attention mask is very important in terms of like this attention behavior of the model. So within the multi-head attention, we use this attention mask. Okay, and the concept is it is the list of binary values like 1 and zeros. 1 represents the real token, and as you know, we paired our input with the paired tokens, and you know that the paired tokens are just the fake tokens that we add to reach the maximum length. Okay, so we have the same length of sequence. So these are the real tokens, these are the padded tokens. Okay, so against each real token we will have 1, and all of the padded tokens we will have 0. So later on we will apply this mask to convert our attention scores to infinity. Okay, wherever we have like the padded tokens, all of the key values we convert them to infinity, so we can then apply the softmax function on it, and we get 0 against all the infinity values. Okay, so this is the attention mask that is very important to build the attention mechanism. Over here we use it. Okay, so here if you can see, this is the mask padding. Okay, and we use it just before the softmax activation on the scores. Okay, so this is about the attention mask. Now maximum length. Okay, so maximum length is the maximum length of model that the model can basically entertain. Okay, so our model by default has 512 tokens, but we can change it. Okay, just like here I have changed it. Okay, so it has now 128. So let me show you. Okay, first let's just clear selected output. Okay, and here I will show you that, let's say I have a sentence as is equal to I like this, and I pass this to the tokenizer. Along with this I pass the truncation equal to true. Okay, and then I am passing padding equal to maximum length, and then I am setting this maximum length to, let's say, 128. Okay, let's quickly check if we can get the result. So this out will contain the result. Let me now print the out. Okay, so here you can see we have the input IDs against the real tokens. Okay, 101 is the input ID for CLS. As I mentioned, that it starts with the CLS token and it ends with the SEP token. So we have these two input IDs, and here we have these three input IDs against I like this. Okay, then we have these token type IDs. We are not going to use it for our task. Okay, so we will drop them. And then we have this attention mask. So you can see now 1 2 3 4 5. So we have 5 attention mask ones that basically represents the real token in our input values. Okay, so these input values we are going to pass to the our model architecture. So over there, this attention mask will help us in identifying the real tokens in our text. Okay, so yeah, this is okay. Now let's copy this one. I have an idea, and come here, and over here I will just search it. Okay, so you can see 105 1045. Okay, so there are multiple 1045. Okay, here it is I. Okay, and this is the input ID against I. Okay, so you can see against I. Now why we have here this small I think you know this now, because this is the DistilBERT base uncased. Okay, so it doesn't basically entertain the capitalization. Okay, so it converts all the capital words into lowercase. Okay, so this, if you copy the second one, this one, okay, and again come here and now search this one. Okay, so let's check. Yeah, I like. Okay, like this one, 2066. Okay, so you can see now we just passed this text to the tokenizer, just like here I mentioned. Okay, and we get these 3 real tokens, token IDs, and 2 extra token IDs for SEP and CLS token. Okay, so this is about the attention mask and the input IDs. We are going to need them, so that is why we explored it. Okay, and now let's move on to the maximum length. So maximum length is basically if you just take this one input IDs. So we provided just these 3 tokens, okay, in our input ID, but the maximum length is 128, and we are fixing the padding to maximum length. So it means the remaining values, like we have 5 real tokens and the total length is 128. Okay, so we subtract it, so we will have 123 padded token values. So these padded values are basically the padded tokens. Okay, so yeah, this is about the maximum length. And okay, one thing about this maximum length is you can consider this maximum length as the context window of this model. Okay, because anything um, that goes beyond the maximum length will not have the position encoding in the uh, position lookup table. Okay, so if you remember, here we have the position lookup table and it is of size maximum length. So anything beyond this 128, let's say 130, so there will be no uh, index for this 130th token, so it will be truncated, the tokenizer will truncate it, and we will not be having tokens more than 128. Okay, so that is about the maximum length. Okay, now let's conclude the topic. Okay, so these are the important things that we are going to use in our model, as I mentioned. Okay, so vocabulary size, padded token, maximum position token, embedding, that is the maximum length, and attention mask. So attention mask, maximum position, and vocabulary size, we are going to use them, and this is what we need to build our uh, model architecture, specifically the embedding layer part. Okay, um, and also this padded tokens are important for the multi-head attention layer side. So overall, the architecture will be using this information, this data from the tokenizer, and we will then build our model architecture that is compatible with these values. Okay, so this is it for the tokenizer. I hope you enjoyed the lecture. I see you in the next lecture.